All right, welcome. Good morning, good afternoon, good evening, wherever you might be. Thanks for tuning in. Jim, I do have the one minor correction for you. It is the Johns Hopkins University, and unfortunately, they beat that into your head so much, I have to correct everybody who does it. But
Brilliant.
it's a
I
little
actually
mistake.
said that wrong my whole life.
No, it's just a little tease. I get it all the time. So today, as Jim mentioned, I would like to talk to you about fighting marketplace scams using community-driven AI. And kind of the story under the story I would like to tell you all today is how people, individuals, entrepreneurs, in my case, think about problems they see in the world in terms of data, and then convert those problems into usable data, into usable pipelines, into potential solutions to those problems. So you can think of this entire talk as one big case study in how feature engineering and feature stores are used to solve problems that people see out in the world. So let me first introduce myself. My name is Sanan Ozdemir. I am many things. I am an author. I am a founder, a former theoretical mathematician, current machine learning engineer, but I'm also a teacher and an art collector and an art lover. So among these things, what is most relevant today is I started a company back in 2014, went through YC, an AI company, conversational AI, fun stuff, my field, we exited. And during COVID, my co-founder and I got into collecting art and also in particular, NFTs during the big boom. So I also wanted to talk about how that pairs with my love of feature engineering. As you can see here, my cat Euclid is posing next to the batch of my most recent Manning book that Jim referenced, the Feature Engineering Book Camp. So to back up a little briefly, we all think this is probably pretty familiar to most people. The modern ML engineering tends to follow this kind of flow where we acquire data, we do labeling and feature engineering, experimentation, model training, deployment. There's some form of steady state. And then during that steady state, we're monitoring for drift detection, and then all of that loops on itself. I'm sure we'll see this graph or flow in some form many times today. But I would like to zoom in a little bit on the feature engineering aspect of it. Now, to be lazy and borrow from my own book, I like to break down feature engineering into four smaller umbrella terms, where feature understanding, structuring, optimization, and evaluation, which all flow into how do you collect data from disparate data sources or potentially disparate data sources and understand them, structure them, optimize them, and evaluate them, all for the, in most cases, purpose for optimizing some machine learning pipeline. Now, again, we can talk about how all of this will work in production, in experimentation phase and training phase, but most people tend to think about feature engineering as something that just, quote, has to be done, or just, well, it's whatever makes the models happy and not error out. But when I think about feature engineering and the fact that I've written 2 books on it because I love it so much, I think about a few things. A majority of data scientists' time is spent working on the actual data itself rather than the models. Now, this is not really news to most people who work in the field. There's the running joke that 80% of time is spent cleaning data rather than building your models. And that's true for a reason and to an extent. But it's one of the reasons we should be working on data as much as, if not more than working on models, is most boosts in machine learning performance are often attributed to feature engineering over model tuning. And I think, and again, anyone who's ever worked in the field would very likely agree with that statement, that your biggest boosts in your gains, performance are mostly attributed to what you did to your data, whether it's getting data from a cleaner source, optimizing it yourself, a new text vectorization algorithm that you've discovered, whatever it might be for your particular field. Those often lead to the best boosts in model performance rather than hitting your head against the wall doing model tuning. Another reason is that bias in machine learning pipelines, which is something I lecture on quite often, is often best mitigated at the data phase, in the pre-processing phase of model training. And more so than not in the last 5 years or last decade, I would say, more and more people are paying attention to bias and fairness in machine learning pipelines, as they should. And part of my thinking on feature engineering is it is the perfect time to recognize and mitigate such biases, which, again, so much so it's an entire chapter in my new book. Now, at the end of the day, feature engineering is often how we turn unusable data into useful and explainable data. Now, let's tie this back all into the topic of today. Is we are no strangers to fraud as a species and a society, right? We all have a story of either ourselves or someone who has been tricked or duped or bamboozled in some physical or perhaps even a digital marketplace acquiring digital assets. Now, all these marketplaces are fraught with fraud. There are plenty of news articles where you can bring up people who are talking about massive scams in physical marketplaces. Facebook Marketplace is now being one of the biggest marketplaces out there in the globe, and how scammers are using that to target people everywhere, not just in the US or in the UK or wherever the marketplace is settled. Now, even more so, in digital marketplaces, and when I say that, I mean mostly in the sale and resale of digital assets, in most cases NFTs, they are especially full of fraud. Most bad articles you see about NFT marketplaces and scams talk about how it's just so many. So much so that in the biggest marketplace for NFTs, OpenSea, they admit that 80% of the NFTs on their platform are spam or scam or fraud. So as someone who frankly loves the space of collectibles, both physical and digital, you can see at my walls, I have everything ranging from the centuries old oil paintings to a KAWS figurine, contemporary, to a modern sculpture right up just off screen. This is and I can show you my wallet if you're so interested, but this is a field that I really care about. And so it's a field that I want to understand. So this is the feature understand what makes a scam or a spam happen in such a marketplace or in such communities, which we'll talk about how we're going to get most of our features, not necessarily from a marketplace, but from communities of people who also care about this, and then use that data to feed back into it. So let's see that. So before we do that, just to kind of zoom in on why I will be talking about more digital than physical. Physical marketplace scams is kind of what most people think about. It's mostly secondary market where people are reselling goods to each other, and they range from mislabeling items like this is an iPhone 14 when they actually give you an iPhone 10, all the way to being robbed at gunpoint. So there's a large spectrum of the kinds of scams and fraud that can happen on physical marketplaces for physical goods. Digital goods, they're often less physically threatening to yourself, to your body, but they're easier to conduct at scale, which is why marketplaces like OpenSea see 80% of their assets being spam, whereas it's not even near that for physical marketplaces, but that's the trade-off, volume versus the severity of the actual fraud. Now, if you're not familiar with NFTs, and in particular NFT communities, they tend to thrive on a platform called Discord, which is like Slack, but originally was for video gamers to chat and talk to each other, but was kind of adopted by the NFT community. And this is how most NFT communities, frankly, all major NFT communities build their base on Discord or something homegrown themselves. And Discord, most often, are public and open for anyone to join. So this is kind of where our data story begins, because to build a community-driven AI, you have to go to the source of your data, the community. So here I'm just showing two Discord communities for two pretty big projects that I collect, World of Women and VFriends. So in each of these Discords, they have some form of a way to let the community tell them about potential scams. Usually that comes in some channel about reporting scams or scam alert or what have you. But it's so ubiquitous that any NFT community you join will often have, of the three main channels they have, some general chat for people, some announcements to tell the community about updates. And right there next to both of those very important things are scam alerts, because they know this happens all of the time. So there's community-driven vigilance, and that vigilance is going to help us transform it into machine learning pipelines. These Discord communities are very proactive to alert their fellow NFT lovers about these potential scams, which is good for us because that means data is constantly flowing in the form of free text, which, for NLP experts, that's obviously what we want. These free texts are flowing freely in these Discord communities, just waiting to be ingested. They will also negatively react to posts that they think are scams. So in Discord, you're allowed to react to any message, just like in Slack with emojis, and most people will put siren emojis or thumbs down emojis when they discover some kind of a scam or feel like someone is being spammy in their behavior. The point is, communities act as their own sheriff and therefore can provide the data to fight these scams at scale. This is useful for us who are building a community-driven marketplace to understand how Discord communities think and act on scams to help us understand how we can automate it. Quick differentiation between spam and scam. Scams are intentionally fraudulent messages who are generally designed to steal your money or assets. Spam are just messages designed to get your attention. They can be scam, but spam messages could also just be someone really excited about their own project and just telling the world about it in an albeit annoying way, but technically not fraudulent way. We'll be focusing more on scams just because they are more dangerous, obviously, but we'll see how they're in a way linked. Because the first case study is my own Twitter. So as of today, this was a few days ago, I get targeted with scams at least once a week. And they tend to, recently at least, look like this. And I'll talk about why I said recently in a moment. They'll look something like this, where some Twitter user will tweet something about a whitelist, which is what WL means, and then they'll mention like a dozen people and with a link to what seems like a legitimate website for some NFT project. And in this case, another popular project I'm involved with, Alien Friends. Now, because I am a part of a community in Discord for Alien Friends, as soon as I saw this, I, to be frank, knew it was a scam, but I always like to check my sources. So the first thing I did was go to Discord and check if this was already reported, and it was. So this exact scam was already reported by someone in the report scams channel telling us about the scam. So it kind of confirms the suspicion that when scams happen, it is often important to check the community to see if it's already been reported. Now, me, the data scientist, takes it one step lower and says, well, how would I know without actually checking the scams site or the scams channel? Well, in this case, there were a few dead giveaways, and not to put this bot user on blast, but this person is clearly fake. They have 0 following, 0 followers, and they joined Twitter in October, which is this month. So their account at the time of me getting the tweet was at most 8 days old. So young account, no following, no followers. This is clearly a fake account. And also, to go even one step further, the website and the Twitter handle they referenced was not an associated website with the project. So in that case, for a human at least, it was extremely easy to detect that this was a scam, or at least a very, very likely scam message. Now, breaking this down into features and what will eventually become in be stored in our feature store, we're really talking about 2 entities, messages and actors. You have scam messages who are written by bad actors, and each of these are going to have a different set of features to maintain. Now, in these kinds of problems, it's easy to kind of catch yourself in a bit of a catch-22, where you could say, well, you're only a bad actor because you're sending scam messages. And this is a scam message because it was being sent by a bad actor. In my last case, I noted that the user was fake, and that was one of my primary reasons for thinking the message itself was scam. And you can kind of get yourself caught in this loop, and said in a different way, you can design the problem in many ways. So when you're designing the problem to be machine usable, you have to define features that are generally independent of one another, but at least related on the entity level. So as an example here, if I'm trying to decide if someone is a bad actor, I could use features like the number of likely scam messages that they've sent, or the number total messages that they've sent, and use presumably a ratio between those two to understand whether or not the person themselves are just more likely to be a scam artist in general. I could also use more simple features like the account age, or the number of followers, the number of friends, depending on where we're looking, but on Twitter, that would be the number of following, et cetera, et cetera. Now, the first feature, the number of likely scam messages, obviously refers to the other entity messages. So to understand whether or not a message is scam, I could use independent features of actor so as to avoid that loop from actor to messages, kind of confusing the problem even further. So for scam messages, it comes down to a data scientist, for the most part, to think about what kinds of features are going to be useful. And this is for thinking back to the feature engineering, we have understanding, optimization, structuring, and evaluation. Now we are discovering features, we are structuring them, we are optimizing them. We can think about the number of people who are mentioned in a tweet. In my case, there were at least a dozen people mentioned, not just me. Uses of common scam phrases. Now, this is a domain-specific problem for the most part. And for example, the WL I mentioned, or you've been whitelisted, is a very common phrase in NFT communities, telling someone that they are eligible to receive an NFT, and which gets people excited because they get their NFT. Counts of negative reactions in public spaces. This is an easy way to help us also label messages ourselves from the community. Or the person who's claiming to be the admin of a project, very often, or one of the most successful types of scams are people who are claiming to be the creator of the NFT project, because most, if not all of this is occurring online. Most people don't know what the creators of NFT projects look like. It's hard to Google them. They have some profile picture that is not actually their own face. So it's relatively easy to claim to be the admin of an NFT project and not actually be one. And that can happen privately in your direct messages. So to me, this comes down to having multiple feature drivers, meaning the number of times someone is mentioned in a tweet, or uses of common scam phrases like you've been whitelisted, tend to be more bag of words style features, right? The count of mentions or counts of these known phrases. These are simple bag of words features for those in the NLP field. We can go one step further and talk about negative reactions in a public space. Now, easily, this could be done, although tediously, this does exist as packages. You can get a dictionary of negative emojis. And one step deeper, to understand if someone is claiming to be the admin of a project, that's more of a semantic field that we would have for a raw text. This could be accomplished using some transformer-based model like BERT or GPT. We can use these large pre-trained language models, which is something I tend to specialize in understanding these semantically derived features, like, is this person pretending to be the admin of a project, yes or no? And these large semantic models can help us understand those at scale. So how do feature stores fit into all this? Well, feature stores are how we can create, define, and iterate on these features, because the goal is to discover the strongest possible community-driven features to build an AI that can detect these scams in real time. Centralized feature locations to make experimentations reporting easier, and things we'll likely hear a lot today, sharing features across our organization and monitoring these features over time to detect drift and skew. Speaking of skew, hindsight tends to be 20/20. Historical users and message data have already been reacted and reported, but that's not true for a message that was sent 2 minutes ago versus 2 years ago. So we can't necessarily rely on these time-reliant features like the number of reactions, the number of retweets, but we have to be more reliant on time-agnostic account age or message content. Now, age might sound like it is not time-agnostic, but the account age tends to scale linearly with time units, if you can believe it. So for that reason, I tend not to think of it as necessarily time reliant because it's a simple linear scaling. Now, scams do drift, but they often tend to drift in more of a step function. Scammers will find a method that works and then stick to it. This was just literally yesterday. Someone tried a very similar scam with me for a fake Nickelodeon NFT that they thought I would like because I am a millennial in my 30s and I loved Hey Arnold as a kid. So I'm a good target, but clearly this person is also fake. So these things are continuously happening. These scams are constantly happening. So at Shiba, as we're building a community-driven marketplace for fine art collectibles, both physical and digital, it is imperative that we use this data to build this community-driven AI that can loop back on itself to drive out scammers and spammy behavior. This behavior is not just for detecting bad actors, but it's also for something a little bit more high level. So we get the speed and performance of a feature store and pre-trained language models, but we also get to use the opportunity to educate people on what constitutes a scam or spam and help them as they're writing a message to someone and tell them, hey, what you're writing looks like scam. And if you keep writing messages that look like scam, you are likely to get reported by either us or someone else. And if someone is genuinely not trying to sound like a scam, but for some reason are writing in that manner, it is a chance to educate people on how to message better in these kinds of marketplaces. Because at the end of the day, we deserve to shop in peace. And with use of feature engineering, feature stores, and community-driven AIs, we can at least strive for a world where no one gets to be scammed. And in the meantime, everyone should be vigilant. They should know what to look for, specifically in the domain that they are. If you're into NFTs, hopefully this was a little bit helpful in that regard. And if you see something, say something. Report these bad actors, because that is the data that will be used for AI companies like ours, in a way, to build these community-driven AIs to help drive out these scammers. So that's it. Thank you so much.